Hi, this is a new DC to DC version, 500 watts. This is a step up, or what is called a boost converter, and it is a new revision from the previous one, and I'm just trying to find out what are the differences between this, because this one is 500 watt and this is only 250 watts, which is exactly half. And I'm just very curious to understand how come they got twice the power and it looks more or less the same. So maybe we will start with the coil itself. Okay, this one is 1.26 millimeters, and this one, okay, this one is 1.69. And why this is matter? Because if you have a wider coil, so you can drive more current, of course. Other than this, all looks much or less the same. There is another difference. Here we have two diodes, so probably the current that available to the forward current through the diode is higher than this one. This is an integrated diode. This looks like a transistor or a MOSFET, but it is not. This is a diode which has a common, I don't remember if anode or cathode, and then the other two diodes. So maybe let's try to Google it and see what's the difference between these two. So the diode here, it's very hard to read. This is 2100 CT. 2100 CT. Okay, so this one is 20 amps, 100 volt Schottky diode. And what does they mean by 20 amp? Average forward is 10 amp. Okay, so you have two diodes, but each one can deliver 1 amp, so total for both is 20 amp. So let's see this one. This is SK 106, but no, it's the same. It's 10 amp Schottky rectifier. It's look the same current. Maybe the dissipation factor, because this is a bigger package size and it is on a heatsink. All of the PCB is a heatsink, so probably you can deliver more current in this way. 2SKP3, let's see, 60 amps, and this is till 75 volts. And again, I would like to get 100 volt, so I will need to replace it, same as I did in this version. Other than this, all looks the same. So let's see if it's the same component here. I'm searching for the R4. Okay, so first I would like to test it as is with the components that we have. It should get up to 50 volts. And then we'll do some changes and see if we can modify it. Okay, so minus is here, plus will be here. So 0 in, 0 out, as expected. Now we go to 1 amp 12 volts. We have already 16 volts. So let's go to maximum. Maximum is this side. And we are at 55 volts. By the way, if you will notice, the capacitor out of to 50 volts and we end 54, this is not a very good sign about the design they did, because you need to take some spare, and this is more than need to be in this place. So now let's modify it and then we test it. Okay, so after doing all the modification on the new board, so let's check it. So I remind what I did. I changed R4 to 1.8 kilo ohm. This capacitor is 220 microfarad for 100 volt, of course. And I changed the MOSFET here. This is the MOSFET, this one. I change it to one that capable of 100 volt. I think it is 20C100, or I'm not sure about the number, but this is a MOSFET for 100 volt and with very low resistance. So let's power up. Hopefully nothing will explode. Okay, so we already have 63 volt. It should get above 75 volts. Let's go up. So we have 70 and 80, almost 80 volts, 79 volts. Okay, so the modification also works for this board, no problem, the same components and very good. So that's all, thank you and bye.